Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 18 of a unit electrostatic potential and capacitance. In this session we are going to discuss the questions that has been previously asked, the questions in the medical examinations. In the previous class we were discussing about the questions that have been asked in the engineering questions, that has been asked in the engineering competitive examinations. But even if you are an engineering aspirant, you are going to opt for the JEE mains and JEE advanced, please go through this, because we cannot directly segregate it that this can be asked only in JEE or this can be asked only in NEET. So please go through this. And one more thing, that as you did in the previous class, please go through this question with your pen and paper on. Yes, you must attempt this question as it has been asked in an examination. So what you are supposed to do is, you just go through the question, pause your video, solve on your pen and paper, and just check the answer. If it has been done, well done. If it is not being done, don't worry, I am there on the other side. Just play the video and look at the solutions and again reattempt it. This will help us to clear this unit from what is potential to the at the end it's in capacitance. Yes, so are you ready? Can we start? Let's begin then. This is the first question of today's session. Let's have a look what question is all about. What they say is that two charges Q1 and Q2 are placed 30 centimeter apart. This is the Q1, this is the Q2, okay, as shown in the figure. A third charge Q3 is moved along the arc of a circle of radius 40 centimeter from point C to point D. The change in the potential energy of the system Q3 by 4 pi epsilon naught K, where K is, you need to find out the K. So how can you do this? What can be done? Yes, there are two charges. One of them is the Q1, another one is the Q2, and these two charges are placed at the 30 centimeter apart as shown in the figure. A third charge is there, which is a charge Q2, which is to be moved along the arc of a circle of radius 40 centimeter from point C to point D, and the change in the potential energy. So if you remember this session, that this is the question of reconfiguration of a system. Yes, so what I supposed to do is the change in potential energy. What I need to do is I need to simply put it's in potential energy final minus potential energy initial. Yes, it's a potential energy final minus potential energy initial. Now the situation is something like this, that this is point C, this is point A, and let's say this is point B. This is of 30 centimeter, this is of 40 centimeter, and this two charges, this is Q1, Q2 and Q3. Okay, great. So here it is, it's a Q1, this is as a Q2 and this as a Q3. So what I need to do is I need to just give them a numbers. It's a first, it's a second, and it's a third. So let's form a pair. UI initial, it's 1, 2, 1, 3 and 2, 3. This would be the initial situation. Now they want that this charge, that the situation will look something like this. It's a Q1, it's a Q2. Initially Q3 was here and it is moving in the circular arc, something like this. This is Q3. The separation between this is, this was 30 and this is 10 more. Yes, something like this. So what should you do? It's a final would be again the numbering should be the same. It's a 1, it's a 2, it's a 3. So this would be equals to 1, 2. Next is the 1, 3. and next is the 2 comma 3. Yes, this would be the situation. So let's write it down, the initial potential energy first. Initial potential energy, it's a 1 comma 2, it's a K multiplied by Q1 multiplied by Q2 divided by 30 centimeter. Now it's a 1 comma 3, it's a K multiplied by Q1 multiplied by Q3 divided by 40 centimeter. And then it's a 2 comma 3, it's a plus of K multiplied by Q2 multiplied by Q3, and their separation, look at this, this is 30, this is 40, so their separation would be a 50 centimeter. This is the situation. This is UI. Now UF, final potential energy, what it would be, it's a 1 comma 2, it's a K Q1 Q2 divided by 30, it's a 1 comma 3. Now 1 comma 3 would be 1 3, it's a 40, so this is K Q1 Q3 divided by 40, and next it's a 2 comma 3, it's a K multiplied by Q2 multiplied by Q3 divided by the separation between 2 and 3, it's a 10 centimeter. So if you observe this very carefully, what you come to know this, what I supposed to do is I need to just find it out, the difference of this. Let's say if I perform work done, that is UF minus of UI, this K Q1 Q2 by 30 minus K Q1 Q2 by 30, this 2 would be a gone, even this 2 would be a gone, only the term that remains is this 2. So what I can write is that work done is equals to UF minus of UI, that would be equals to only this term, it's a this, and this will be a remain, it's a K Q2 Q3 divided by 10 minus of K Q2 Q3 divided by 50, and I hope you can do the rest amount of thing. Yes, can it be done, or shall I do this for you? Let me help this. It's a 5 K Q2 Q3 divided by 50. I have multiplied and divided this with the 5. Yes, minus of K multiplied by Q2 multiplied by Q3 divided by 50. So this would be 5 minus 1, it's a 4. So this is equals to 4 multiplied by K multiplied by Q2 multiplied by Q3 divided by 50. That's it. This would be the answer. Yes, you need to match this with the options and find out the value of an X. Is it clear? Is it? So can you do this? Have you landed on the same answer? What was yours? Great. So ready for the next question? Let's have a look what the question is saying. What the question is saying that as per this diagram, a point charge plus Q is placed at the origin. Okay, this is the charge Q. Work done in taking another point charge which is of minus of Q from the point A, its coordinates are 0 comma A, so this distance must be an A, to another point B, their coordinates is A comma 0. Okay, so even this distance is A along the straight path AB. So I need to carry this minus Q from this to this. So what I need to do is I need to find out the work done, and while finding out the work done, I know that work done should be is equals to Q multiplied by delta V. This Q would be that charge which is to be shifted, that is minus of Q, multiplied by delta B, it's a VB minus of VA. I hope this is clear. So let's first find it out that what is the potential at B. Let's first write it down, the potential at B and then potential at A. So if I understood that what is potential at B, this potential should be due to this charge. It's a K into Q divided by A. Potential at A, what is it? It's a K multiplied by Q divided by A. This is VB, this is VA. Now if I observe this very carefully, then this VB and this VA are the equal. So if these two are the equal, this is minus of Q multiplied by 0, that would be the 0. Yes, this is the answer. Yes. So can you do this? What was your answer? Is it same? Is it? Great. let's have a look. The next question, yes, the question says that potential of a large liquid drop when 8 liquid drops are combined is 20 volt. Then the potential of each single drop was, okay, so how could I do this? The potential of a large liquid drop when 8 liquid drops are combined, yes, so this is the potential of combined drop, this is the potential of combined drop, and I need to find out the potential of each single drop. So how can I do this? Let's first go with the, here hint is provided, yes, but let's first go with the calculation. Yes, how could I do this? Let's suppose there are 3, 4, 5, 6, 7 and 8, and this is going to make this bigger drop. So it's an 8 multiplied by 4 by 3 pi r cube should be is equals to 4 by 3 into pi into capital R cube. This has been gone. So what I can write is it's r is equals to 2r. Yes, this r is equals to 2r, and that's, let's suppose that charge on each drop, charge on each drop is q. So charge on bigger drop should be 8 into q. Yes, it's a n into q times. Yes, I hope this was clear. So now potential of bigger drop, it's a k multiplied by capital Q divided by capital R. It's a k multiplied by q, it's an n into q divided by r. This r can be represented as 2r, and this is k into 8 into q divided by 2r. This is potential of bigger drops. Yes, so this is something like this. Yes, so this VB should be is equals to 4 multiplied by KQ by R. This KQ by R is the potential of smaller drops. It's a V multiplied by S. This is VB is equals to 4 by Vs. So potential of bigger drop is given as a 20 volt, and you need to find out the potential on each single drop. So that can be written as this is 20 is equals to 4 multiplied by Vs, and this Vs can be calculated as 20 by 4. It's a 5 volt. I hope this is clear. Is it? Okay, one more thing. If you remember this formula, this is 20 is equals to 8 to the power 2/3 into V. Yes, you need to calculate this and the things will be done. So I request you people who are the medical aspirants, please remember this formula, because what happens that for the medical examinations, specifically in the NEET examinations, you are going to have only a single minute to solve this question. Yes, so if you go with this is very good approach, but the thing is that you might not able to do this within a single minute whole solutions. Yes, so request you to, if you can remember this, please go for it. Please remember this can be done. Yes, so if you go with the if you have gone the with the last lecture as well, yes, there one question was there which was the question for the what would be the potential, what would be the capacitance if n number of identical drops has been merged. That question carries the 4 information: total amount of charge, total potential of the bigger drop, capacitance of the bigger drop, and as well as energy of the bigger drop. So please go for it. And just remember these things. Please. Yes. So let's move to the next question. Are you ready? Let's look at this. What the question says. According to the question, they says that figure shows 3 points A, B and C Yes, this and this. In a region of uniform electric field, the line AB is perpendicular and BC is parallel to the field lines. Then which of the following holds good? Yes, I want the correct option. So what can we do? What can we do? If you remember the equipotential surfaces, it says that, what does it say? Yes, what does it say? What is it? Yes, it says that direction of electric field is towards the decreasing potential direction of electric field is towards the decreasing potential. That means that, look at this, direction is in positive x direction. So that means voltage at A and voltage at B would be higher as compared to the voltage at C. Yes, one more thing, that point A and point B are on the same location. They says that line AB is perpendicular. Yes, so these two are at the same location. They must be having the same voltage or potential difference. It's a VA equals to VB, and this value will be bigger than, it's a greater than VC. So this would be the correct answer. VA equals to VB, which should be greater than VC. I hope this is clear. Is it clear? Yes. Can you do this? Great. Let's move to the next question. The next question says that if a charged spherical conductor of radius 10 centimeter has a potential V at a point distance 5 centimeter from its center, okay, then the potential at a distance 15 centimeter from the center will be. So first have a rough sketch of this and let's have a look. This radius is of 10 centimeter and it is having a potential of V when it is at 5 centimeter. Let's say this is 5 centimeter. So potential at point P, this is point P. Now as I know that point P is the inward points, and let's say charge Q is given, then Vp is equals to KQ by R. Yes, it's a KQ by, my radius is 10 centimeter, so this is 10. Now I need to find out potential at a point distance 15 centimeter from the point. So let's suppose I want to find out the potential at this point. Let's say this is point R and this is 15 centimeter. So potential at R would be equals to K multiplied by Q divided by 15. Yes, I hope you understand this. And Vp was KQ by 10. Let's have a ratio of this. So this is VR divided by Vp. It's a KQ by 15 multiplied by KQ by 10. This has been gone. It's a 2:3. So this is VR multiplied by V. So this VR should be equals to 2/3 of V. I hope this is clear. Yes? Did you get the same answer? Did you get the same answer? Are you sure? Great. Let's move to the next question. Yes, what this is, it's an electrostatic potential of a uniformly charged thin spherical shell of charge Q and radius R at a distance R from the center. Yes, the electrostatic potential of a uniformly charged, a thin spherical shell of a charge q and radius r. Charge is q, radius is r, at a distance of r from the center is. So what they want? They want that this is spherical shell and it is given a charge q. This is having a radius of r and they want it at a distance r from the center. Yes. So there could be a two cases. There could be a two cases. In one of the case, let's say distance is at this point. It is inside. And in another case, distance is. This is the case where r is greater than r. And this is the case where r is less than r. So let's write it down this as a 1. Let's write it down this as a 2. So in the first case, as this point is lying outside the shell, I should write it as a k q divided by r, while k should be equals to 1 upon 4 pi epsilon naught multiplied by q divided by r. And in the second case, this point lies within the shell. It's a k multiplied by q divided by, as it is within the shell, I am going to use the complete radius. It's an kq by r. I hope you remember this. It's in 1 upon 4 pi epsilon naught multiplied by q divided by r. So this is 2 are the potential. So when point lying outside the shell, it's a q divided by small r, and when point lying within the shell, it's a q divided by r. Yes, so for point outside, it's a q by 4 pi epsilon naught r, and for point inside, it's a q by 4 pi epsilon naught r. Yes. Did you understand this? Are you sure? Let's move to the next question. Do it quickly. Make it fast. What the data says. The potential of an electric field produced by a point charge at any point xyz is given by, it's a V is equals to 3x square plus 5, where x and y are in meter and V is in volt. Okay. The intensity of the electric field. Yes, you have been given potential and you need to find out the electric field. So how can I do this? I am having a relation. It's a E is equals to minus of dV by dx. As I can see that I am having an only x. So no need to write a del V by del x because the only one dimension has been given. So if I write this, it's a minus of d by dx of 3x square plus 5. Then the thing will be E of x should be is equals to, let's take a minus on the outer side, and d by dx of 3x square, it's a 6x plus 0. So I need to replace this by the minus of 2. It's a minus of 6 into minus of 2. A 0 would be has been gone. It's a minus minus plus 12. Unit, it's a volt per meter, or you can even write as a Newton per coulomb. Yes, it's a volt per meter. That has been given in option. Is it clear? Yes. Can it be done? Can it be? Are you sure? Can it be done? Great. So let's look at the next question. Yes. Let's have a look. What this is, an electron of mass m and charge q is accelerated from rest, okay, in a uniform electric field of strength E. The velocity acquired by it as it travels a distance L. Oh, very good and very logical question. Very, very logical. Yes, even this is a very good example where they have combined the concept of class 11 and class 12. So what can you do? What is your mind thinking? What I supposed to do is that I know that work done is equals to change in kinetic energy. I hope you remember. It's a work energy theorem that you might have been taught in the class number 11 work power and energy unit. Yes, work done is equals to change in kinetic energy, and work done is equals to force into displacement as well. So if I use this, this work done is equals to force into displacement. Here only the electrical force is acting. So this is equals to charge Q multiplied by E. F is equals to QE, that we learn in electric charge and fields. The distance X, here the distance given is L. Yes, so this Q into E into L should be equals to half mv square minus of half mu square, as they have given starting from the rest. So this would be a 0 because started from the rest. So what they required, they required a velocity, so v square should be is equals to 2 multiplied by Q E L divided by m. So v would be equals to, it's a square root of this, it's a 2 Q E L by m to the power 1 by 2. That's it. Done. Yes. What was your answer? Is it same? Yes. So will you be able to solve this kind of questions? Are you sure? Are you? Let's have a look to the next question. What this says, that a gang capacitor is formed by interlocking a number of plates as shown in the figure. The distance between the consecutive plate is given and the overlapping area of the plate is given. Okay, the capacity of the unit is, so I need to find out the capacity of a unit. So what I need to do is, first let's find out that what is the value of an equivalent capacitance. So what should I do? In the first situation, let's calculate the number of plates. This is first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. Okay, so what number of capacitors can be formed? Let's have a look. This 2 will form a one capacitor, it's a first. This 2 will form a second capacitor. This 2 will form a one more. This will fourth, this will be the fifth, this will sixth, this will seventh, and this will eighth. Okay, so this all together can form 8 capacitors. And if you observe this very carefully, let you give me a hint, that let's suppose I have connected this with this kind of battery. Then you can say that their alternate plates are connected. Every alternating plates are connected. So if I rearrange this, then this could be something like this. Yes, I hope you understand this. Did it? Can you see this? Yes. So this, let's suppose this is plate number 2. Let's suppose that this is plate number 1, and again plate number 2 and 3 will form one more capacitor, then 3 and 4 will form one more capacitor, and onwards. So if I write down the capacity C, total 8 capacitors would be formed. So my C equivalent should be equals to 8 multiplied by epsilon naught multiplied by 8 divided by D. So this is equals to 8 multiplied by epsilon naught multiplied by area. The area of cross section, it's a 5, and this is 0.85. It's a 5 centimeter square divide by 0.885. 885. Yes. Again, this is in centimeter square, so that needs to be converted, and this is in centimeter, so that needs to be converted. I hope the things are clear. Yes. So I hope you can do the rest amount of thing. That means the solving of this question can be done. Yes, you should replace the value of an epsilon naught. What is it? What is the value of epsilon naught? Yes, it is an 8.85 into 10 to the power minus of 12. So just replace this. That can be solved by this. Yes, and this 2 would be a cancel out, and I hope you can do the next. So let's have a look to this question, a very important, and this is a very fresh pattern of question. Yes, let's have a look. What they say is that a number of condensers, each of capacity 1 microfarad, and each one of which gets punctured if a potential difference just exceeding 500 volt is applied, are provided. So what the data is saying, that this all capacitors are there which can have a maximum potential difference across them is 500 volt. You cannot provide them more than 500 volt. If you have been provided more than 500, if you have been provided more than 500 volt, they just got punctured. Next, an arrangement suitable for giving capacitance of 2 microfarad across which 3000 volt may be applied requires at least how many capacitors? So what you supposed to understand before attempting this question is that, let's say, suppose if I have a certain capacitor, something like this. This is voltage V1, this is voltage V2, this is voltage V3, this is voltage V4, and their net voltage is V1 plus V2 plus V3 plus V4, something like this. Yes, and if I have been arranged capacitors in parallel, then my voltage of every capacitor, let's say, suppose this is V1, this is V2, this is V3, their voltage would be equal. I hope you remember this. Yes. So when this kind of question has been asked, always remember that in a first task, always arrange your capacitor in series to fulfill requirement of voltage. This is first task. And then arrange same number of capacitors in parallel. Yes. Okay, what does it mean that first arrange them in series and now then in parallel? And okay, go through the data one more time. What you require 2 microfarad capacity and 3000 volt. What you are having, that we have 1 microfarad and maximum 500 volt. What we require, we require 2 microfarad capacity and 3000 volt. This is the requirement. So what I supposed to do is, what I can consider is that 500 volt is there and I require 3000 volt. So what I can do is, I can arrange this 6 capacitors in the series. So it is 500 plus 500 plus 500 plus 500, something like this. So thing will look something like this: 1, 2, 3, 4, 5 and 6. Yes, each one can bear a maximum of 500 volt. So this in a totality, it's a 3000 volt. I hope this is clear. Yes, but one more thing that you missed out is each one having a capacity of 1 microfarad. So this is 1, 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 this is 1. So this C equivalent of this branch is 1 by 6 microfarad. Now what you require, we require C equivalent of 2 microfarad. So what we are supposed to do is, we are going to arrange this, we are going to arrange such branches in parallel, because it will make sure that 1 by 6 plus 1 by 6 plus 1 by 6, and that will become a 2. Yes, and when I arrange certain branches in parallel, it will not increase my voltage, because in parallel voltage will remain the same. So the thing will be, what I required, C2. How many such branches are required? N multiplied by 1 by 6. So this N equals to this 12 branches are required. This is 12 branches are required. So I require 12 branches, something like this. There are 6 capacitor in each branch. 1, 2, this is the second branch, and such this 12 branches are required, and this 12 branches each having a 6 capacitor. So total capacitors that I require, it's a 12 branches multiplied by 6 in each branch, that is the 72 capacitors. I hope this is clear. This is the only way. Some of the author says that you can go with the trial and error, but it takes a very high amount of time. So don't go for it. Always consider what we have, what we require. Then always stick to this, that first always arrange your capacitors in series to fulfill the requirement of voltage, and then find out the how many number of branches are required to fulfill my requirement. I hope this is clear. Is it clear? So can it be done by you guys? Are you sure? So let's look at the next question. Let's have a look at this question. What the data is saying is that an energy E is stored in a parallel plate capacitor of C1. That means a capacitor C1 has been stored, it has been charged, and energy E has been stored in it. And identical, that means having the same capacitor, but it is an uncharged, which is a C2, is connected to it and kept in contact with it for a while and then disconnected. The energy stored in C2. So what the situation is, it must be something like this, that this is the capacitor C1. Let's assume that its capacity is C, and it has been charged with certain voltage V, and due to this it is having an energy of half into C into V square. Now one more identical, that means it must be having the same energy, but it is uncharged. Capacitor has been come into a contact. This is C1, which value is C. This is C2, its value is C. Has been come in contact with it for a while and then disconnected. So let's first find it out, the VCM. Now VCM would be equals to, it's a C1 V1 plus C2 V2 divided by C1 plus C2. As this is uncharged, that means its V2 would be a 0. It's a C into V divided by 2C. This is CC gone, and VCM would be equals to V by 2. That means the new capacitor, it's a capacitance C2, has been charged by a potential of V by 2. So if it has been charged by a potential of V by 2, the thing would be something like this. It's a C, even this is C, and we can assume that that has been charged with a potential of V by 2. So this is C1, value C, this is C2, value C. So energy stored in C2 capacitor is equals to half into C into V square by 4. So this is equals to 1 by 4 multiplied by half CV square. It would be a 1 by 4 times of E. This is energy stored in capacitor 2. That's it. What was your answer? Is it same? Is it? Great work. Ready for the next question? Let's do it very quickly. Look at this. The question says a 10 microfarad capacitor is charged to a potential difference of 1000 volt. Okay. The terminals of the charged capacitors are disconnected from the power supplied and connected to the terminals of an uncharged 6 microfarad capacitance. What is the final potential difference across each capacitor? So indirectly they want that what should be the value of an VCM. So the situation is, initially this is the capacitance of 10 microfarad and that has been charged with a battery of 1000 volt. It's a 1000 volt. Another is the capacitance, it's a 6 microfarad and their voltage is 0. Now What I need to find out, I need to find out the final potential difference across each capacitance. So what I need to do, I need to find out VCM, which is C1V1 plus C2V2 divided by C1 plus C2. So this C1, it's 1000 multiplied by 10, it's 10,000 plus 0 because this is uncharged. This is uncharged. Divide by C1 plus C2, it's 10 plus 6. This is 16 microfarad. This is 10 plus 6. This is 16 microfarad. So this is 1000 by 16. It's 500 by 8. It's 500 by 8 volt. And this would be the answer. I hope this is clear. Yes. 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 So let's move to the next question. Look at this. What this says is that two plates, they are charged to plus Q1 and Q2, are brought closer to form a capacitor of capacitance C. The potential difference across the plates. Yes, a very logical question. Very logical question. What this says is that this is one of the plate, this is second plate, and this plate has been given a charge Q1. This plate has been given a charge Q2. And let's assume that these two plates form a capacitance of capacity C, the potential difference across the plates. So what I need to first do is that I need to find out that this is the first plate, or this is the plate first side of this plate, this is the second side, this is the third, this is the fourth. Yes, I hope you remember what I'm trying to do. It's a first charge, it's a second side, it's a third side, it's a fourth side. So what would be the charge on the first side? You know that it's a Q1 plus Q2 by 2. Here the charge will be Q1 minus of Q1 plus Q2 by 2. If I do this, it's a 2Q1 minus of Q1. So this is equals to Q1 minus of Q2 divided by 2. And here it is negative of that. So it is a Q2 minus of Q1 divided by 2. Here the charge on one side and charge on fourth side would be the same, that you know, it's a Q1 plus Q2 by 2. Now what you require? You require the potential difference. So what I know is that V is equals to Q divided by C. Yes. So when I write this V is equals to Q by C, I must consider that this should be charge of positive plate. This should be the charge of positive plate, which in my case, if you observe this, it's a Q1 minus Q2 by pi. They have said that Q1 is greater than 0, so it is a positively charged plate. This is the positively charged plate, and this would be the negative charged plate. Yes, so that should be is equals to Q1 minus of Q2 divided by 2 into C, and that's it. This should be the answer. This is the potential. Yes, maybe this is the new concept for you guys. Yes, but now onwards you must be able to do this. Yes, ready for the next question? Are you ready, guys? Yes, let's have a look. The next question, let's have a look. What this says, the two condensers are there, one of capacity C and another of capacity C by 2. Let me write this. It's a C and this is C by 2. Are connected to a V volt of battery as shown. The work done in charging fully both the capacitors. Okay, work done in charging fully both the capacitors. So what I can write is that this is situation where something like this. This is V. These two are in parallel, and as they are in parallel, if I find out their equivalent, then it's a C plus C by 2. Yes, this is C plus C by 2. That stands to 3 C by 2. I hope this is clear. And this work done, or technically this is energy stored in capacitor. This is energy stored in capacitor. This is equals to half multiplied by C equivalent multiplied by V square. So that should be 1 by 2 multiplied by C equivalent. This is 3C by 2 multiplied by V square. So that should be 3C by 4 V square. It's a 3 by 4 C V square. Yes, this would be the final answer. Yes, yes. Are you sure? What was your answer? What was it? Is it the same? Great. You are doing pretty good. Well done. Let's move to the next question. What they say is that the potential energy of a charged parallel plate capacitor is U naught. Okay. If a slab of dielectric constant K is inserted between the plates, then the new potential energy will be. Okay. So what they want, the potential energy of a charged. This is charged already. This is charged. Yes, but they have not said. That it is connected with the battery. So I assume that it has been disconnected from the battery. So initially my energy was Q square by 2C. Yes, and this capacitor is not being connected with battery while insertion of dielectric slab. So charge remains the constant. Did you remember this? Did you? Great. So my charge remains the constant, but capacitance will increase. So my final capacity would be equals to Q square by 2 multiplied by, I know that capacity will increases by K times. So if I take a ratio, it's a U initial where Q square by 2C. So if I do UF by UI, this would be is equals to Q square by 2KC multiplied by Q square by 2C. This Q square has gone. This is 2C has gone. So this UF is equals to UI divided by K. This is it. Yes. What was your answer? Is it same? Does it? Yes. Great. Let's move to the next question very quickly. Look at this. What they say is, according to them, if the energy of a 100 microfarad capacitor charged to 6 kilovolt, please look at this, it's a kilo, could all be used to lift a 50 kg mass, what would be the greatest vertical height through which mass could be raised? Yes, again a question where concept of 11th class and concept of 12th class has been merged. So energy stored in capacitor could be written as half CV square, and the greatest potential energy, that would be equals to M into G into H. Yes, I am going to do this task with the help of half CV square. So it's an half CV square should be is equals to M into G into H. So this H should be is equals to half CV square divided by M into G. I'm sure you can do this. Yes, it's a 1 by 2 multiplied by capacitance. It's a 100 microfarad. Micro stands for 10 to the power minus 6 multiplied by, this is 6 kilovolt. This is 6 into 10 to the power 3 whole square. Divide by M into G. Mass is the 50 kg. And let's take this as a 10. You will have an answer. So 10 meters. Yes. So let's move for the next last question of this session and this unit. Let's look at this. What this is. According to them, an uncharged capacitor with a solid dielectric is connected to a similar air capacitor. That means air has been there as a dielectric, is connected to a similar air capacitor which is charged to a potential of V naught. Okay, if the common potential after sharing of charges will become a V, then the dielectric constant of the dielectric must be. So do you understand what the situation is? According to them, one of the capacitor is there. Let's assume that it is a C, is being charged with a potential of V naught. Yes, and another capacitor is there. But it has been filled with the dielectric. That means something like this. Again, it's a similar capacitor. Capacity would be C, dielectric would be, let's assume that it is a K. And this is uncharged. That means its voltage would be a 0. When I connect this to, their capacity, their common potential would be V. So this is C, this is K into C, that you understand. I need to find out the dielectric constant of the dielectric medium. Yes, so what I can write is, it's a VCM that would be equals to C1V1 plus C2V2 divide by C1 plus C2. The common potential will become a V. This is equals to C into V naught plus, this is Kc, but as it's uncharged, it's a 0, divide by C plus Kc. So if I solve this, it's a C into V naught divide by C as a common, and this is equals to 1 plus K. So if I simplify it, it is 1 plus K, that should be is equals to C V naught divide by C into V. So this gone. So K is equals to V naught by V minus of 1. This is equals to V naught minus of V divided by V. This should be the value of dielectric step that has been inserted. Yes. So let's wind it up. Yes, this is the second session and this is the last session of the previous year asked question series. Yes. So up till now we have been done with the electrostatic potential and capacitance. That's it from here. Yes, but you need to practice or you need to revise, because the unit number 1, which is electric charge and field, and this unit electrostatic potential and capacitance, has a very high capacity to be asked in the examinations for NEET as well as JEE. So please do it. Even these units are very lengthier. Yes, so it will take a time to command over it. So you need to revise it again and again. Please do it. This will help us. Thank you. Have a good day. Take care. Bye.